Hi, welcome to a new session of analog circuits. In today's class, we are going to see the application of PN junction diode in the form of series clippers and parallel clippers. In our class 1 under clipping circuit, we have seen the negative series clipper circuit whose output is in this fashion. When input is voltage is applied through the diode and the output voltage is calculated across the resistance. Then we have seen also the positive series clipper circuit whose output is in this fashion, which is you can see it is like a half-wave rectifier output but in the reverse direction. Then we have seen the negative parallel clipper circuit whose output is almost equivalent to the negative series clipper circuit, and finally the positive parallel clipper circuit whose output is again which is equal to the positive series clipper circuit voltage. Now, ultimately, the conclusion is that based upon the diode position, whether it is in series fashion or in parallel fashion, we can make use of the output voltage from the given input voltage. Hence, it is acting like a perfect switch. Now, what happens if we take any reference voltage which is connected in series with the resistor or in series with the diode or in combination of resistor in series with reference, and that output voltage is estimated, how to get this condition and this output voltage. For that, we need to understand the behavior of the diode for positive half cycle and negative half cycle. So the positive half cycle, when the voltage is less than the reference voltage, what I'm going to say is that when the input voltage is less than the reference voltage, the diode depends upon the reference voltage, and this makes the diode to be off. And when the diode is off, the current, it is 0 amperes and it flows through the resistor. And since the diode is off, it has become an open circuit, but the current, which is 0 amperes, when it flows to the resistor, it becomes short circuit, and hence the output voltage is equal to the reference voltage. This is the first catch. Then you see what is going to happen when reference voltage is less than the input voltage. When reference voltage is less than the input voltage, the diode depends upon the input voltage and becomes on by getting short circuited in this fashion. And let us calculate the value of output voltage by applying KVL into the input loop. I'm going to get the V in is equal to the resistance voltage plus the reference voltage, and the resistor voltage is nothing but the resistor multiplied with the diode current. In fact, the current which is flowing into the circuit is nothing but the diode current. So is diode current, I want to know, it is nothing but the V input minus V reference by resistor. That is the diode current of this circuit. And when you take the output voltage in terms of the developed voltage already in the resistor, so the output voltage is a combination of resistor voltage plus the reference voltage, as you can see from this particular diagram or circuit. Now substitute the value of resistor voltage. The resistor voltage is nothing but the resistor multiplied with the diode current. So the diode current, when it is taken, it is nothing but V in minus V reference by resistor. This makes the resistor get cancelled and the reference voltage also getting cancelled. Hence the output voltage is equal to the input voltage. So under positive half cycle, we have two conditions. First, the reference voltage is dominant when it is greater than the input voltage. The output voltage is equal to the reference voltage. But when the reference voltage is less than the input voltage, the output voltage is equal to the input voltage. Okay. And what happens when this negative clipper circuit is given as input as negative input supply? So during negative half cycle, the diode depends not only on the reference voltage but also on the input voltage, and input voltage is negative for the negative half cycle and reference voltage is positive. Hence the diode is already off. It becomes again a strong off by getting open circuit in this fashion, and naturally the output voltage is equal to the reference voltage. In order to understand this, you can see here we have taken the sinusoidal input signal in this fashion, where we have also taken a reference voltage like this. Then the output voltage, you can see how it is obtained. Only for the positive peak it is obtained in this fashion. Negative peak is clipped off. Okay, and this voltage, when you estimate with the input voltage, the waveform design is also changed. So this is because of the reference voltage. So that is how a reference voltage is playing its importance, and the output voltage is getting completely clipped according to our requirement. So this particular circuit and the output waveforms are the outputs of negative clipper circuit with positive voltage as reference. I hope you understand this is what has happened exactly. I'm showing here a MATLAB output also. You can see here I have taken 100 volts 50 hertz as input voltage, and it is applied to the diode with 50 ohms, and that is in series with 25 volts. So you can see the MATLAB model and its output in this fashion. Clear? I can also show you this MATLAB model directly. Uh, you can see a negative series clipper circuit with positive reference voltage. As I told you, I have taken the value of voltage as 25 volts. Resistor, you can see I have taken as 50. Then input voltage is 100 at 100 at 50 hertz, and stop time I have taken 0.04. Then I'm running this. The output you can see over here. Yeah, this is the output you can see. As I told you, the output voltage you can see, the reference voltage is taken as 25. So 25 is there, and below 25 it is clipped off. So it's a negative series clipper circuit, and the negative voltage is clipped off. Okay. Similarly, if at all I want to know uh, what could be the value of the positive series clippers with positive reference voltage. So positive means what? I'm changing the diode position. You can see over here, diode position is changed, and also input voltage I have changed the value from 25 volts to 50 volts. And if at all I run this, now you see the positive uh, waveform of the output. Here you can see it is clipped off, whereas the negative is sustained, and hence the positive series clippers resembles this kind of waveform. So likewise, I have taken different uh, conditions of diode as well as the resistor. So you can see here a positive series clipper with positive reference voltage. These are the conditions of on. You can see V output is equal to V input during cycle from 0 to reference voltage value. And this is how the circuit would be. And during positive half, when reference voltage is less than input voltage, the diode, which depends upon input voltage, it makes the condition to get off, and this open circuit makes the output voltage is equal to the reference voltage. And then for the negative half cycle, the output voltage is equal to the input voltage. Then what would be the output waveform? You can see this is the output waveform, just what we have seen in the MATLAB. Okay, so this is how the behavior of the clipper circuit. You can understand the combination with series or with positive reference voltage and with negative reference voltage. So this is the MATLAB model as I already showed you. Now let us see negative series clippers with the negative voltage as reference. So you can see here there is a negative voltage of reference. Now this is the MATLAB model. You can see that negative reference voltage I have taken as 25. Then what is going to happen? You see here, this negative voltage, it is clipped off at 25. That is also minus 25. So minus 25 is clipped off. Then you take a positive series clippers with negative voltage as reference. So it is a positive clipper circuit with negative voltage as reference. Again I have taken here 25. You can see here again at 25 the positive is clipped off. Okay, then what happens with positive parallel clipper with positive voltage as reference? So this is the circuit diagram for positive parallel clipper circuit, and you can see the output waveforms. Now it's a positive parallel clipper. So positive parallel clipper with positive reference voltage. You can see here it is clipped off at 25. Then a negative parallel clippers with positive reference voltage. With positive reference voltage I have selected here as 30. So you can see here 30. This output is obtained and the negative waveform is clipped off. Then a positive parallel clipper with negative reference voltage. With negative reference voltage you can see I have selected the voltage value as minus 10. So at minus 10 this is how the waveform is obtained. And for the negative parallel clipper with negative voltage as reference, this is you can see I have taken here as 60, and that to reference negative value. So minus 60 you can see over here, and the negative clipper, so the negative waveform is clipped off. So that is how you can make use of the diode, and this is a strong application of diodes in its behavior in clipper circuits. So I hope you like this class. Please share among your friends, subscribe to this channel, and press the bell icon for the future notifications. Stay connected to our channel for different subjects. In the next class, again, I'm going to take transformer problems, that is EMF problems, what we have seen in the 15 days before class. I have taken a transformer. So parallelly we are going to learn about machines, and parallelly we are going to learn about switches. Like we are we are continuing with the diodes, then we are going to see what is a BJT, that is bipolar junction transistor. Then we are going to see the MOSFET behavior, and later on we are going to see what we can do with this switching arrangements in our future classes.